Hey Calculus, welcome back. Our objective today is going to be to find intervals of concavity. I've got the checklist on the screen. You know what to do from here. Okay, so write this statement in your notes for me. If f is increasing, then what can you tell me about the first derivative? Also, the word we want to tie to slope, right? So if f is increasing, then f prime is what? Then f prime is positive. Right? Again, if my function's increasing, my slope must be positive. F prime, the derivative is positive. Okay, so make sure you've got that written down. Now, can we extend that? Okay, so what if we take the next derivative? If f prime is increasing, then what do you think you could conclude? What do you think about this? Then f double prime is positive. Right? So if f is increasing, the first derivative is positive. If f prime is increasing, the second derivative is positive. Okay? Okay, so I'm going to force a pause on your screen. Can you please copy what I have? Okay, we are back. So I've got two pictures. F is concave up and f is concave down. So up like a cup or down like a frown, alrighty? But we want to put these terms in more of a calculus perspective, all right? So when we're talking about especially Calc 1, differential calculus, let's analyze the slopes, okay? So let's take a look here. If I draw some tangent lines, so about that, I've got a decreasing line, so a negative slope, and then I've got a zero slope, and then I've got a positive slope. Right? So my slopes went from negative to zero, so to positive. So are my slopes getting bigger or smaller here? My slopes are getting bigger, right? And again, what do I tie to the slope? The first derivative. So slopes, I'm going to put f prime increasing, okay? Now from that previous slide, we said that f prime, if f prime is increasing, that is equivalent to saying that f double prime is positive, right? So I'm going to put greater than zero there, okay? So now let's look at the converse. F is concave down, okay? Well, let's draw some tangent lines here. Here I've got an increasing tangent line, so positive slope, zero slope, a negative slope, right? These are not perfect, but you get the idea. So if I go from positive to zero to negative, then those values, those slopes are, in this case, what? The slopes are getting smaller, they're decreasing. So I'm going to put f prime decreasing, which is equivalent to saying that the second derivative is what? Negative, right? So all of these are equivalencies. If f is concave down, that's the same thing as saying the first derivative is increasing, which is the same as saying the second derivative is positive. And by the way, it's also the same as saying that the tangent lines sit below the curve. Do you see that? How all the purple lines are sitting underneath the original black curve? Now, these are all synonyms. If f is concave down, that's the same as saying f prime is decreasing, the first derivative is increasing, which is equivalent to saying the second derivative is negative, or that the tangent lines sit above, right? The curve. Okay. Okay, so let's write some definitions. I'm going to force a pause on your screen. Just copy what I have. All right, so the sign of f double prime, the second derivative, gives you the concavity of f. In other words, are my concaves up or concave down? So if the second derivative is positive, then the original function f is what? Concave up. And conversely, if the second derivative is negative, then f is concave down. Good. Okay. Now, I do want to review, though, what we did with the last lesson. So let's also put this in your notes. So go ahead and copy this next sentence, and then we'll fill it in together. Good. So the sign of the first derivative gives me what about f? This tells me the increasing, decreasing behavior of f. Okay, so if the first derivative is positive, then f is what? Is increasing. And if the first derivative is negative, what can you tell me about f? It's decreasing. Okay, and any abbreviations I use are totally fine to use on the AP exam. So INC, DEC, we know those are increasing, decreasing. You can use CU and CD for concave up and down, respectively. Okay, so hopefully, not surprisingly, our strategy is going to be super similar to the last lesson. It's just that instead of analyzing the first derivative and then making a number line, we're going to analyze the second derivative and make a number line, okay? So whereas we filled in the top for f prime, and the sign of f prime gave us the increasing, decreasing behavior of f, now we're going to fill the top part of the number line in for the sign of f double prime, which will tell me if f is concave up or down, all right? Okay, so example 1, can you write f of x in your notes, please? And go ahead and write it, and then also find me the second derivative. Hit continue when you got the second derivative. Okay, so here's what I have for the second derivative. Nowhere is it going to be undefined. There's no fraction here, so let's go ahead and set this equal to 0. And let's factor out a 12x, which leaves me with x minus 2. Okay, so now I'm going to make a number line with the zeros of that. Okay, so let's take a look here. That first factor, 12x, is it ever 0? Yeah, it's 0 when x is 0. And what about x minus 2? Is it ever 0? It is 0 when x is 2, right? So I'm going to put 0 and 2 in my number line. Now, instead of labeling this f prime and f, we're going to label it f double prime and f. Okay, so now coming back to our boxed expression there, if I plug in a value in the first interval, like -1, I get a negative times a negative, which is positive. And then I don't have any even multiplicities, so we will just alternate after that, right? So now be really careful, because I'm no longer finding the increasing, decreasing behavior of f, right? So now if f double prime is positive, what can you tell me about f? F is concave up. And if f double prime is negative, f is concave down. And then again, f would be concave up here. Okay, so if you read this little note here, it says if f changes concavity at x equals c, then the corresponding point is called a point of inflection. So I have points of inflection at 0 and 2, because you can see f change from concave up to concave down, and then concave down to concave up at those x values. So let me show you what the graph of f looks like. So again, this is y equals f of x, and we got points of inflection at x equals 0 and at 2. Okay, so let's analyze those real carefully. It said what we got in our analysis was that that first interval from -infinity to 0, f was concave up like a cup. So see that curvature there. If I were to draw some tangent lines, they would all sit underneath the curve, right? And then it switched from concave down from 0 to 2, and this looks really good as well. If I draw the tangent lines, they're going to sit above the curve there, and then it switched back to concave up from 2 to infinity. Again, my tangent lines sit below. Okay, so that is our analysis. So you and we'll make sure that we understand the difference between concavity and increasing and decreasing, right? Because if I take a look at like this interval here, my function is concave up, but it's also decreasing. Okay, so you can have kind of a mix and match of your aspects there. Okay, so example 2, find the intervals of concavity for y equals 1 over x, same idea. Will you first find me the second derivative and then hit continue once you've got that? All right, so this was a rewrite and then power rule twice because second derivative. Then I went ahead and rewrote it again as 2 over x cubed. Okay, so we want to double check, where is the second derivative, 0 or dne? Notice it's never going to be 0 because the numerator can only be 2. So let's check for dne, check where the denominator is 0, and that is going to give me just x equals 0 to put on my number line. Okay, so let's do that. I've got 0, and I'm going to this time label f double prime and f. How do I know that? Because I'm checking for concavity as opposed to increasing, decreasing. That's really the word I want to zone in on. Anytime you see concavity, think second derivative, okay? All right, so let's pick a number in the first interval. So I'm going to box that, and that's where I'm coming to check. So if I plug in -1, I'd get 2 over -1 cubed, which is -1. My multiplicity on the x, even though it's in the denominator, I can check it, it's odd. Odd is opposite, so I'm going to switch there, okay? So f is going to be concave down for -infinity to 0 and concave up from 0 to infinity. All right, so I would like for you to try example 3. You don't need to copy the graph in your notes, but I would like for you to decide the signs of both the first and the second derivative. For the 4 indicated points, we are not going to do point D. Okay, don't worry about that. So let me do the first one with you. I've got the answer there, but for the first derivative, what do you want to check on f? You want to check increasing, decreasing. So since f is increasing, the slope is positive there, then the first derivative is positive, okay? Now for the second derivative, the sign of f double prime tells you what about f? It tells you the concavity. So I can tell that my original function's concave down there, so that means f double prime is going to be negative, okay? So go ahead and write the answers for B, C, and E in your notes, and then when you're ready to see the answers, hit continue. Okay, answers are on the screen. Bring any questions to class and go ahead and do a 1 to 2 sentence summary for me in your notes, and I will see you next time.